Hello everyone, this is Nirmit and today we are doing problem of the day for 21st of May 2026. I know this question is coming out from my channel a bit too late, but as they say, it's never too late. So we are doing question number 3053, that is find the length of the longest common prefix, and it is a medium level question. The question says that you are given two arrays with positive integers, array 1 and array 2. A prefix of a positive integer is an integer formed by one or more of its digits starting from its leftmost digit. For example, 123 is a prefix of the integer 1 2 3 4 5, while 2 3 4 is not. A common prefix of two integers a and b is an integer c, such that c is a prefix of both a and b. For example, 465555359 and 46554 have common prefixes 465 and 4655, while 1223 and 43456 do not have a common prefix. And we need to find the length of the longest common prefix between all of these pairs x and y, such that x belongs to array 1, y belongs to array 2. Return the length of the longest common prefix among all pairs, and if no common prefix exists between them, then return 0. Cool. So the question is a medium level question, and before seeing the examples, first of all let's see the constraints so that we have an idea key of what time complexity we should think the solution of. The constants are okay. Array the length of the array is in range 5 into 10 to less than 5 into 10 to the power 4. So we can obviously not think anything in bgo of n square. We need to think of something along bgo of n or bgo of n log n. Okay, so now let's move to the examples and first try to understand the examples. You are given array of 1, 10, 100 and array 2 is 1000. Let's understand it with a whiteboard so that it's more clear to all of you. So our first array is 1, 10, 100 and our second array is 1000. Now from 1, 10, 100 you can what prefixes you can have. You will check the prefixes possible here. You first go at 1 and you can see that here only one prefix is possible, that is 1. Then you go for 1 0. Here you can have 1, you can have 1 0. Then you go for 100. For 100 you can have 1 1 0 1 0 0. Prefix, if for those if you don't know, it's the substring of like for a given string. If you are asked its prefix, it's any number of elements taken from first to ith element, and you should not leave any elements. You can leave elements from the end. And for 1000, the prefixes that you can have are uh, 1, 10, 100, 1000. So then we check both of these prefix arrays and we find that what is the longest common prefix we have. 1 is common in both, 10 is common in both, 100 is common in both, but longest is 100, and the length of longest common prefix is 100, that is a 3, that is 3 digits. So we will give 3 for this case. Similarly for this case where we have 1 2 3 4 4 4, let me write that also. We have two arrays in this case, 1 2 3 and 4 4 4. Here if we find the prefix of each of these integers, for first one the prefix will be 1 2 3 only, and for the second one it will be 4 4 4 only. So we will not have any common prefixes here, and hence our answer will be 0. So yeah, now going to the approach, first of all the very intuitive, very simple approach that comes to is the brute force. Obviously that's the first approach that comes to us in interviews. And in brute force what we will do is that we will pick an element from array 1. We will check its we will find one of its prefix, and then for that prefix we will check for all the elements in array 2 and try to find that prefix. And then we similarly we will do for the second element, then for the third element. We will do it one by one, and this approach will obviously be big O of n square, that is the size of array 1 and array 2, that will be n into m. In worst case it can obviously go n square and exceed our give a TLE to us. So we have to think on lines of more optimal approach. Now here we can achieve optimality by, and yeah, in that approach there is also, if you can see, a lot of redundant work. First I go for one, I find its this one prefix, then I scan this entire array, find one, then I do go for 1 and 10 here also, because it's also have its prefix as 1 and 10, and then I find for both 1 here, then for 10 here, then for this one I again checked 1, I again checked 10. Like I'm checking 1 here 3 times, checking 10 2 times, which is totally not feasible. It's we are doing redundant work, and whenever we are doing redundant work, you should know that a more optimal solution exists there. So here we can do it three ways, sorry, two ways basically. There are actually three ways, but I will be telling you the best ways here, the easiest ways here. So one, we can maybe convert each of the integers to string, and then we can do operations on that. But we can obviously also go along with integers, as that will save us more time. So what am I thinking here? That here I am doing redundant work. I am again and again computing 1 1 1 3 times. What if I maybe have a data set where for 1, 10, 100, I find the prefixes of all of these. I see the prefix of element at first index, that is 1. Then I go for the prefix of 10. I see 1 is there. I see 1 is the prefix of 10. But 1 is already present. So I will not put it here again. I will skip it. Then I will see 10. The 10 is not present. So I will put it. Then I go for 100. For 100, 1 is present. I will not put it. 10 is present. I will not put it. 100 is not present. I will put it. And then similarly, we do for 1000 also. Let me just enter prefixes. Yeah. And similarly I do for 1000 also. For 1000, I, instead of creating a different prefix array in 1000 once again, what I can simply do is I can just check one by one that what are the elements, the prefixes that are in this array 2, are they present in this one or not. So like here we have 1000. I am not creating a different prefix array. I get first prefix of 1000 as 1. I see 1 as present in this array. So I keep a count of my answer. My answer, which was 0, now it is 1. Now I see the second prefix. The second prefix that I can get is 10. 10, now the size is 2, which is greater than 1. So now the answer changes to 2. Now I see the next prefix, that is 100. It is also presented in the, present in the prefixes array. So now I update answer to 3. And then finally I see the final prefix, that is 1000. But 1000 is not present in the prefixes array, so our answer will not update, it will stay same, and 3 I will return as the answer. So here what we are doing is, since we want a data set which stores only unique occurrences of an element, we will use a set here, and for better time we will use unordered set. So now let's move to the implementation part. So first of all, I create a unordered set st, and then after that I will iterate through each element in array 1, and then for each of those elements I will find their prefixes. So what is prefix? Like if you have 1 2 3 4, so its prefix can be 1 2 3 4, 1 2 3, 1 2 1 1. So if you can see, I am just doing by 10. Like if I do 1 by 2 by 10, I just get 1 2 3. Then if it's I do it by 10 again, I get 1 2. So that is what we will be doing here also. I will be as soon as I get I take the first element, then I check if this element, like every element is a prefix of the element itself. So first of all, I check if this element is present or not. So in the set already. So I do while not st dot count I to check if that element if that prefix is already present in the prefixes set or not. And I also want I to be greater than 0, so that I don't get trapped into an infinite loop. If the element is not present in the prefixes and if it is not equal to 0, then I just insert the element in the prefixes array, and I divide the element by 10, so that I can move on to the next prefix from 1 2 3 4 to 1 2 3, from 1 2 3 to 1 2. And this is done for all the elements in the array 1. Yeah, so that's it. Our first part is completed. Now we need to go to the second array and have to find the longest common prefix. So I first declare an answer array integer to where I will be storing my answer, and then I iterate through each element in array of 2. And here, while iterating through each element in array of 2, I won't be finding its prefix and storing it again like I did in the array of 1. I just will be matching if the prefix which I generate from a particular integer from array 2 is that present in array 1 or not. So my condition still remains the same, while if the element is not present, if a given element is not if a present in the prefix array and I is greater than 0, I keep dividing it by 10. And as soon as I get in, I exit this while loop, and if I have a valid prefix such that that prefix is greater than 0. So I will just update my answer with the maximum of answer, and here I need the number of digits. I need the length of the longest common prefix, so that will be the number of digits. So instead of running a different loop of count digits and then finding digits in a big of digits time, I can just simply use a log function of I plus 1, because for any digit, if you can find any decimal number, if you find its log base 10, do its floor and add 1 to it, it will give you number of digits in that number. This is a mathematical trick. So if I do this, and then I can just simply return answer, so this will give me the correct answer for this code. You might be wondering here, why are we doing I less than equal to 10 and then checking if I greater than 0. Let me explain it with a basic example here. If suppose this was our array in like we have talked about it initially, this was our prefixes. Now when I had 10003, so I according to our condition, I first see that is this 1003 present in my st or not. This is my st, this prefixes is my st. So I see that this 1003 is not present in my st and this is greater than 0. So I do its by 10, that just changes it to 100, and still 100 is not present in the array. Then I do its by 10 again, now it's present. Now in st 100 is present. So just quit the I just quit the sub array. I just quit the while loop. This is because if 100 is present in st, then 10 will be also present and 1 will also be present for sure. And I am only concerned about the length of the longest common prefix that is present. So I don't need to check for 10 and 1. I just see for 100. 100 is present, I greater than 0, so I find the number of digits and I update the answer variable accordingly. And if I just run it, let's check if it's correct. Yeah, and our code is correct, it passes all the conditions. I can just run it now, and let's go. We are passing all the conditions. So yeah, that was the approach for doing this question. I hope you like this video, and yeah, keep maintaining that streak, keep doing problem of the day daily, and if there's anything I can help you out with, reach out to me in comments. Thank you.